God, please, no! No! No!
So if you're comfortable doing your own motorcycle maintenance, replacing the clutch friction plates on your bike is a pretty straightforward job. I mean, you remove the side cover, undo the pressure plate, springs, swap the plates out, put it all back together, and you're done, right? Well, that's not the case on a KLR650, and this particular clutch has given me more setbacks and grief than I care to mention. In fact, if I had hair, I would have pulled a fair amount of it out by now. Now, all this stems from a lack of good information online for the average home enthusiast, and the sheer number of different clutches that have come in this bike over the years, which was a surprise to me. I mean, this engine has pretty much remained unchanged since its introduction in 1987, and even then, it was more of a update and an overbore to an existing KLR 600 engine. What I didn't know, and I bet you didn't either, was that the KLR 650 has come with 4 different clutches over the years and its various iterations, and the engine has pretty much remained unchanged. Yes, sure, the 3rd gen KLR 650 did get fuel injection and a number of other engine updates, but the clutch that's in that bike is the same one that's in this one, which you could buy before the 3-year KLR 650 production hiatus. So why did Kawasaki change the clutch on this bike so many times, and for what reason? And what do you need to know if you're refreshing the clutch on your KLR 650? I'm going to answer that today because regardless of what year KLR 650 that you own, this is the definitive guide to parts, components, and how to replace them, plus 1 or 2 pitfalls that we'll try to avoid. I'm Rod, and this is Rod Rides and Wrenches.
Let's start with the clutch parts that have changed through the years. First, I'm going to quickly mention the KL and KLR600, since these bikes use the first variation of clutch parts in the KLR series of motorcycles. The KLR600 was built from 1984 to 86, and this bike uses the following part numbers for reference. It's worth pointing out that the clutch friction plates are carried over into the first generation KLR650, but the springs, steel driver plates, and basket received updates in the 650. With the exception of the clutch basket, which has a different primary ring gear, I would think that some of these components would be backwards compatible to the 600 if you can't find what you need for a 600cc bike, since a lot of these parts are now obsolete. The first generation KLR 650, built from 1987 to 2007, carries over most of the components from the 600 up to the 1995 production year, with the following exceptions. I did mention that the clutch springs were updated for the 650 as well as the steel driver plates. The steel plate thickness is the same as in the KLR 600, so I'm going to assume that the plate is made from a different material or came from a different supplier, requiring the part number change, since otherwise they appear the same and interchangeable. The KLR 650 springs were slightly longer at 34 millimeters versus 32 millimeters in the previous 600cc clutch. In this video, you will see the spring part number and length change through various years of production on the KLR 650, but it is interesting to note that all the KLR clutches, once the springs are installed, are compressed to a height of 23.3 millimeters or 0.92 inches, regardless of the original spring length. As the springs get longer, they have a lower spring rate and hopefully offer the rider an easier clutch pull. If you've experienced the difference between a KLR 600 and a KLR 650 clutch, go ahead and fire a comment in below. In 1996, Kawasaki updated the clutch components in the KLR 650. I would say this is probably the most common clutch to obtain parts for, since these parts remained pretty much unchanged through to 2011. This means this particular clutch spanned the late first generation and early second generation bikes. The big change here is the clutch now uses 8 friction and 7 steel driver plates as a result of a new clutch basket. Now, this 1996 and later clutch basket will no longer accept a kickstart retro kit, since it lost the spur gear on the back of it. Funny enough, most parts fiche that you find online still show this gear on the later version drawings, but it's not actually there. Also on this clutch, the release lever and whole side case castings changed. to improve durability, and for some reason, the hub also changed twice from 1996 to 2011. Both components, however, are dimensionally the same, so again, this probably meant that a new supplier was used and a new part number had to be created. It's common to find aftermarket replacements for both the friction and steel driver plates up to the 2011 model year, and this is exactly what has led to my personal frustration on my 2013 bike. If you search online, you'll typically see replacement clutch parts from companies like EBC, Barnett, or other no-name clutch discs on Amazon and eBay, all for the KLR650. But these plates only fit the 1996 to 2011 and a half KLR650, and these kits have fitment issues that I'll cover shortly. For now, I'm just going to say that Kawasaki OEM parts are your best bet for whatever year bike you own. On the topic of friction plates, dimensionally, all the various Kawasaki friction fiber plates on the KLR at first glance appear to be the same through all the generations and have an inside diameter of 123 millimeters or 4.84 inches. The proud or major outside diameter of all the various discs are 158 millimeters or 6.22 inches. All the plates apparently are supposed to have the same thickness as well, 3 millimeters, and a service limit of 2.7 millimeters. Most aftermarket kits will come with 8 friction plates. Why couldn't you just use 7 of those fiber discs in the old or newer KLRs that only call for 7? Now, initially, I was told that regardless of what year of KLR650 you had, the fiber plates were exactly the same, regardless of the fact that the part numbers changed in mid-2011. Since then, I've gained some insight into using these aftermarket friction fiber plates, or using plates from different years of KLR650s on my 2013 clutch, which I'm going to share. The most common replacement fiber disc manufacturer is EBC, and they claim to make a fiber disc that fits the KLR from 1987 to 2009, and all use the same EBC part numbers, CK4435 or CKF4435 for the carbon fiber infused discs they make. Now, I'm not sure why the EBC discs wouldn't also fit the 2010 and early 2011 KLR 650s, since the clutch is unchanged in those years versus, say, a 2008 or 2009 model. But the EBC website says just 1987 to 2009. In the middle of the 2011 production year for the KLR 650, the clutch completely changed with new part numbers. Although a lot of these parts look the same dimensionally as the previous clutch, the number of friction discs went back to 7 with 6 steel driver plates. But this new clutch uses a 2.25 millimeter steel plate, which is 1/4 of a millimeter thicker, and the springs are now 7 millimeters longer than they were previously, adding 1 more coil. This new clutch shares components with the Ninja 650 and Vulcan 900. It appears the real point of the clutch change in 2011, at least in my opinion, is to accommodate the 2.25 millimeter steel driver plate, which are also used in the ER6N and Versus parallel twin 650 engines. What seems to be more unique about this clutch is that it has a very precise requirement for the thickness of friction and driver plates, and this has led me to today's video. Now, I really had no intention of using much of the footage of me replacing this clutch to any great extent. That wasn't until I put this clutch together to find that it didn't work right, and I didn't really understand why.
Something is definitely not right here.
Other than removing the water pump and replacing the various seals in the pump, replacing clutch friction discs is not much of a riveting YouTube video. But in researching why these aftermarket clutch plates didn't work, I found several other riders in KLR forums experiencing exactly the same issue.
So it wasn't just me.
I also couldn't find anyone else detailing this information on YouTube. So this, combined with the potential to help other KLR owners, means hopefully your watching this video is worthwhile.
Wow. 825 on a good day? 825. This is stack height. The stack height of the fucking plates that came out of here. 832. So the brand new plates are slightly thinner than the plates that came out of the bike. Gen 1 plates are thicker still. And these EBC plates are miles too thick. Just way too thick.
The short story, even though the EBC clutch friction discs are listed by one of our great Canadian parts retailers as fitting my 2013 KLR650 on their website, they don't.
How sure are we about this?
Unbelievable.
After further clarification, this very popular retailer also admitted that their website was in error and they didn't have a solution. The friction discs from EBC apparently work on the earlier clutch, but not on the current. So here are the EBC brand new ones. The EBC discs are slightly thicker than the OEM Kawasaki discs at 3.21 millimeters by my best measurement of when they're stacked together in a set of 7. And this minor difference over the 7 discs seems to have caused all sorts of issues when combined with the current 2011 and later clutch steel drive plate. So this is about 3.5 millimeters of movement on the release rod when you have the EBC friction discs in. Now, we're talking 0.2 of a millimeter thicker per friction disc. The equivalent, well, that's about 2 pieces of paper out of your computer printer. But this minor difference increases the clutch rod free play by about 1.5 millimeters. The release rod, in turn, is restricted in movement, so you have a very short clutch throw and not a gradual engagement at the clutch lever. Just to get these thicker plates to work on the latest generation KLR, you have to run the adjustment of your clutch cable to the maximum. And I have no idea if prolonged use would have caused any further damage to the release lever or the engine case. To sum things up, the EBC plates just don't work, and the OEM friction fiber discs from the Gen 1 and early Gen 2 bike are also thicker and shorten the clutch release arm throw. So the only proper Kawasaki disc for the 2011 and later KLR is the updated part number from Kawasaki. This disc makes the clutch operation smooth, and that's the way it should be. Next up is step-by-step on the friction plate replacement and water pump seal replacement. To replace the KLR clutch, you start by getting your skid plate off, if equipped like my bike. The rear brake pedal also needs to come off, and if you feel it's in the way, you can remove your foot peg. Now, I'm going to drain the cooling system at the water pump. I had to remove the left side panel since the radiator is on that side. Removing the radiator cap helps get the coolant to flow out the drain on the water pump. And I have plans to flush the coolant at reassembly, so this will make my life much easier. Now, I also took the right side cover off, since that's where the overflow reservoir is for the coolant system. But if you're not flushing the coolant system like me, you don't have to remove both panels. Next is to drain the engine oil. And the nice thing about the KLR engine is that it doesn't hold a whole lot of oil. Now, this oil has only seen a few hundred kilometers of use, so it's going to go into a clean pail and hopefully be reused. I should mention that before you start this job, I recommend you get all of the replacement O-rings and seals for this engine cover, plus the 2 gaskets, one for the cover itself and one for the water pump. There is an O-ring at the back of the oil filter housing where it mates onto the engine block, as well as several seals and a tiny little O-ring and shim for the water pump. Now here's a list of all of the components I'm replacing with their Kawasaki part numbers. Now I'm also going to put this list down in the video description. Next up is removing the water pump. Now, I've seen in other videos the suggestion of removing the coolant hoses. I didn't find this was necessary though, and was able to easily move the pump cover out of the way, holding it up there with a tie strap. Removing the water pump impeller is easy enough. Just put the bike in gear and loosen it off. Now, there's a small steel shim and rubber O-ring behind the impeller. My O-ring was nowhere to be seen, so it's timely that I'm replacing all the seals on this water pump. There's a spring behind the impeller that is part of a mechanical seal that's attached to the housing. My spring and mechanical seal seems to have broken loose, so it's a good thing, again, we're replacing all this. Next up, remove the oil filter and disconnect the clutch cable at the cover if you haven't already. To get the clutch cable off at the bottom, you need to loosen it and take it off of the clutch lever at the handlebars to get enough range of movement. Getting the oil filter cover off can sometimes be difficult. Now, there's a spot at the 5 o'clock position where you can use a small screwdriver to get it going. My oil filter, like the oil, has only seen a few hundred kilometers, so I will check it over and reuse it if it looks clean. Now the bolts can be taken out of the cover. All the bolts are the same size on this cover except for one that is about 4.5 inches long that is mounted on the left side of the oil filter. All these bolts have 8mm heads, which is also 5/16 in an SAE size. Getting the cover off can be a bit of a challenge, but Kawasaki gives you this tab to help get the case started. And this calls now for one of my favorite tools, a 36-inch piece of aluminum bar stock. You just need to give this tab a few gentle taps to get the cover separated from the case. With the cover seal broken a little bit, it should just slide right off. We can now remove the clutch pressure plate and springs to access the discs inside. The outer friction discs don't look that bad, and it's always the inner ones that seem to get burnt the most. The steel driver plates should be checked for discoloration and bluing or warpage. The service limit for warpage on the steels are 0.3 millimeters, so you need a completely flat surface like a glass tabletop, or what I'm using, which is a flat mirror, and a feeler gauge to check them. The standard limit of warpage is 0.2 millimeters, so there's not much of a variation allowed. To check the plates, lay them on a flat surface, don't press on them, and then find the high spot and check with your feeler gauge. If you can run the gauge blade under the disc, it's time to replace the steel. If you want to check your clutch basket and hub, now is the time. The clutch basket can get gouged by the friction disc's high points, and the clutch hub can get marred up or deformed from the steel driver plates. I suggest that if you have to replace either of these, that you replace them in a set. Now, mine don't look that bad, but I removed them to check the spacers and bushing on the hub. Be sure to coat the sleeve bushings with oil when replacing or installing the new hub. The clutch hub nut is torqued to 135 Newton meter or 100 pound-feet. Next, I'm going to clean up the gasket surface, and I find that using a bit of spray lube and letting it sit on the gasket for a few minutes helps with getting the material up and off the cases. I use a pneumatic tool with a nylon brush, along with a razor blade attached to my needle nose vice grips, to get the tedious work done in tight areas. Also, while in this area, I accessed and removed the oil pump screen to clear it of any debris, and look what I found.
Now, I just finished cleaning up this side of the case, getting it as clean as I can get it. A couple things to point out. One is you want to make sure you keep track of your dowel pins. There's a dowel pin in the front and a dowel pin in the back of this case cover. The other one is this screen, which is down in the bottom here, this oil screen. And in here, you're going to find all kinds of crap that you need to clean out. Luckily enough, inside this screen, I found this guy, which, if you watched the last video, is actually the other piece of our spring from our doohickey? No, our balance chain tensioner.
Now, I should be thankful that it didn't wind up going through the oil pump, and if you haven't seen my last KLR video, be sure to check it out as I repair what is probably the biggest defect in the KLR650. So if you own a Kawasaki KLR650, regardless of year, you really need to watch it, but not until after you finish this video. Now that the case cover is all cleaned up, I'm going to remove the oil seal and water pump mechanical seal from the engine side case cover. To do this, you can pry on the aluminum flange part of the mechanical seal with a very thin blade screwdriver and gradually work to eventually get the seal free. Now, this is how you would remove this seal if the side case was still installed on the bike and you're only working on the water pump. I decided to punch the oil seal and mechanical seal from the back side since the side case was already off. Now, it takes a couple of good whacks to get the mechanical seal off since it uses an adhesive to help hold it in place as well as friction. By using a driver from the back, I am going to destroy the oil seal, but again, I'm replacing that anyway, and I do feel more comfortable working it free this way than prying against the cover like the Kawasaki shop manual instructed. Once out, you can clean up that surface and prep the new oil seal with a little lubricant.
There's our oil seal. This guy gets driven down with the flush side facing out towards the outside of the bike. The spring that you see on that oil seal faces down into the engine oil. And put just a little bit of spray lube on it, just so it's lubricated when it goes in, like so. I'm just going to gently tap this guy in, which is what we want. And it's seated all the way down. Looks good on the back side.
Next is the mechanical seal, and the Kawasaki shop manual recommends using a 28mm general purpose socket to press the mechanical seal in place, since you don't want to damage that protruding point on this seal. Now, I didn't have a 28mm socket handy, but I did find a 7/8 inch deep socket worked very well for this job.
Yeah, 7/8 is better. So 7/8 was better. Nice tight fit there. Good stuff. See that? And these come with glue from the factory on them, so that'll set up and seal in there.
The final seal install is on the back of the impeller. I found it easier to remove the hard piece of white plastic that is inside the seal and then remove the rubber seal from the impeller. Installing the new one is easy. After a quick wipe and a little lubricant on the seal itself, it just presses in with your thumbs. After getting the proper clutch friction fiber discs for this bike from Kawasaki and giving them an overnight soak in engine oil, they are now ready to install. Kawasaki insists these friction discs are not installed dry, since they will burn up if not pre-soaked. Start with a friction fiber disc against the hub, and then a steel plate, and then another fiber, and repeat until you've installed all 7 fibers and 6 steels. The last or outermost fiber plate is installed in a different position on the hub.
And now the last plate is offset slightly. It doesn't go into the long clutch basket slots. It is offset to this one beside it, and the reason for that is to prevent clutch chatter. Although on this particular bike with its low power output, I don't think clutch chatter is much of an issue.
I also replaced the pressure plate bearing. Now the old one seemed fine, but this is not an expensive part to buy when rebuilding a clutch. Just be sure to lubricate the new bearing before final assembly. I am reusing my pressure plate springs because they're still at 45 millimeters in length. If in any doubt about your own springs, these should be replaced as well. The springs are torqued down in a crisscross pattern to 9.8 Newton meter or 87 inch-pound. Back together, the free play on the clutch rod with these proper Kawasaki discs are only about 1 millimeter, which is significantly less than the EBC friction fiber plates.
So this is 3.5 millimeters of movement when you have the EBC plates in.
Now it's time to install the new cover gasket, and I personally like to use a little bit of black RTV around the bottom of case gaskets to ensure there are no leaks. As I mentioned in my last video, this is a completely unnecessary step for most. I just like to use it to help hold the gasket in place, and a little RTV makes me feel better about any potential leaks down the road.
So now we're ready to put the outer cover on. A couple things. We've got our new O-ring seal here where the oil filter is. Just put a little bit of grease here to help hold that in place. It doesn't get knocked off. Then there's this seal here that supports the crankshaft. And then the final piece we're going to do is put some grease on the balance shaft here that drives the water pump, just to help get that cover slid on properly. Here's a real common issue that people run into with this particular clutch, or any one that actually has a manual throwout for that matter. So as you see, when this is seated all the way down in the top of the case, the arm is not aligned properly in the slot. So just understand that the arm has to be lifted up about 0.5 centimeter, all right, in order to get the throwout in the proper position here on the case. When we install the cover, this lever is positioned like so. Basically, we have the flat part of the clutch lever facing towards the clutch, facing towards the end of the bike. And that way, when we press the cover on, it gets pushed, and our mechanism basically then locks on to this guy right here. And it can be pulled out when we pull the clutch lever. Okay, let's put this guy on. And again, remember that clutch lever has to be positioned a little bit higher and can't be just resting on the case. And when that goes in here, yeah, you'll feel it. It's definitely in.
With the side cover on the bike, I can now bolt it down. These cover bolts are torqued to 8.8 Newton meter or 78 inch-pound. Before going further, I installed a new clutch cable and confirmed everything is working properly. I ran the new cable through the appropriate points on the frame and then started installation at the clutch cover. After the cable is on at the bottom, I can install it at the lever and make some fine-tune adjustments. If I don't have enough travel at the top, I can go back down to the engine case mounts and reset the cable position to get the 2 to 3 millimeters of free play required at the lever.
Yeah, it's a nice gradual clutch movement there. Much nicer.
With the clutch pull finally feeling like it should, and the side cover affixed to the engine, it's time to install the oil filter, water pump impeller, and pump cover.
So now we start putting these components back together. I'm going to start in no particular order, but with the oil filter. We'll put that oil filter back and put that case on. The oil filter is disposable, of course. This one, as I said before, only has a few hundred kilometers on it. I'm going to reuse it. This the tube that goes through the oil filter only goes into the Kawasaki KLR650 the one way, and that's with the narrow end, or the basically the end that's cut down, goes into the block. So we're going to insert it into the oil filter. It doesn't matter which way it goes into the oil filter. The filter itself doesn't have a direction to it. But that where that taper is, that goes into the engine. Then the cover for the outside can go on. There is an O-ring here. Just want to make sure that it's not completely dry. Has some oil on it. It's clean. Not locking any debris in there. It only goes on in one direction, and there's an arrow at the top of it, right here. So that goes pointing upwards in the bike, and this little tab goes against the tab that's on the case cover. Now these bolts are different for the oil filter. They are the shortest out of all the bolts that came off this side cover. Very, very short, guys. And just like the rest of the side case bolts, 8.8 Newton meters. So the next thing we're going to install is the water pump. Now we've installed all new seals, of course, on this pump, but there is a O-ring and a shim washer. So the order that these go on is first with the steel shim that slides over the impeller shaft, and then the rubber O-ring slides all the way down. And then the water pump impeller can go on with our new seal on it. And that twists down. And then finally, we have the nut that holds the impeller on and a washer or shim for that nut that goes on. So then this guy is torqued down to 9.8 Newton meters. So now we've got our new water pump gasket. Goes on like so. There are pins on the cover side to help hold the gasket in place. No additional sealant necessary here. Are 3 bolts that are about 2.5 inches long.
After that was done, and before doing anything else, I filled the bike up with oil, reinstalled the rear brake pedal, and flushed the cooling system with fresh water, drained the complete system including the overflow, and installed Blue Engine ice coolant. The KLR650 can get hot when riding slow on trails and working the engine hard. Now I did want to see if this blue ice coolant is worth all the hype it gets online, and to find out how well it works, as well as some other accessories on the bike I've installed, stay tuned for what's going to be my last KLR650 video.
Thanks for watching this video to the end, and whatever bike you ride, be sure to ride safe.